Charlie, how's it going over here? I haven't heard a peep out of you in almost an hour.
Yeah, and we know how unusual that is. What are you doing that's keeping you so quiet?
Well, Jose, as you know, we're going to talk about scientific inquiry today. I'm just finishing my observations on one of the experiments I conducted this week. It'll show our audience how scientific inquiry works.
All I see is a mess of sugar and rotten bananas. Other than completely grossing me out, I'm not sure how this is going to help us understand scientific inquiry.
This coming from someone who's spending half an hour making lemonade. How's that going to help us?
Hold on, you two. Both of you are showing us exactly how scientific inquiry works, and the fact that it is used by everyone every day. And I do mean everyone, including all of you out there. First things first, though, we need to explain what scientific inquiry is. Okay. Scientific inquiry is the process that scientists use to answer questions and learn about how the world works in an accurate and unbiased way. It uses the same reasoning we all do to solve problems and make decisions in our everyday lives.
Ever decide on what toothpaste to use, or which friend to call and ask over to your house, or figure out why a light bulb may not work?
Ever wonder how dew is formed, or what causes bananas to ripen faster?
Ew, that still grosses me out.
All these questions and problems can be answered using scientific inquiry. And here's how you do it. First, define a problem or ask a question. Then, form a hypothesis about what you think the solution is. Next, plan and conduct an experiment that will give you information you can use to solve your problem. When you're done with the experiment, gather and analyze the results. Then, form a conclusion based on those results. And finally, explain your experiment and conclusion to others. Charlie, why don't you start by explaining your experiment and go over each step one at a time?
Sure, Lori. Let's start with Jose's favorite, the rotting bananas. Now, I love bananas, but the problem is that after a few days, the last one in the bunch is always brown and mushy. So I asked myself, how can I slow down the speed that bananas ripen?
That's the first part of scientific inquiry.
Right. I then thought that the most likely cause was the amount of air around the banana, which made my hypothesis. The more air bananas are exposed to, the faster they ripen.
Stated simply, a hypothesis is an educated guess or a prediction based on the information you have at the time and what you think the answer to your question is. The key to a good hypothesis is that it must be stated in a way that can be tested by an experiment. For example, with the light bulb not working mentioned earlier by Jose, the hypothesis can be, the outlet is not working, or the lamp is unplugged, or the light bulb is burned out.
Next, I set up my experiment with the following items: 3 bananas from the same bunch at the same ripeness, 2 sealable plastic bags, and a paper plate for each banana. I placed 1 banana on a plate uncovered. I put another one inside an open plastic bag, and then sealed a third banana inside a plastic bag with all of the air taken out. With this setup, I made sure that the only independent variable in the experiment was the amount of air each banana was exposed to.
Hey, I know what variables are. They are the factors that have an effect on the experiment. The independent variable is the one thing you change in your experiment, while the factors that stay the same are called the controlled variables.
That's right, Jose. In Charlie's experiment, the controlled variables are the age and size of the bananas, as well as the temperature of the room. This way, the only difference for each banana is the amount of air it's exposed to. Having only one independent variable in your experiment is very important. Even with the light bulb problem, you wouldn't want to change the light bulb and move the lamp to another outlet at the same time. Otherwise, when you turn on your lamp, you won't be sure which variable caused the result you reached. So, what did you do then, Charlie?
Well, I let the bananas sit for 10 days, and I checked them every other day, taking notes on any changes I saw. And after 10 days, here are the results. The banana in the open air, as expected, is now way overripe and has turned brown. The banana in the open bag has also ripened quite a lot, but not as much as the one in the open air. The banana in the sealed plastic bag is still looking good enough to eat.
What you have observed is the last of the 3 types of variables, the dependent variable. This is the variable being tested that is reacting to the independent variable. In this case, the ripeness of the banana is the dependent variable. Now, all you need to do is form your conclusion.
Based on the data I observed, I feel that my hypothesis is correct. Air has a direct impact on how long it takes for bananas to ripen. The more air the banana had around it, the quicker it ripened.
And since you've explained your experiment so well to us, others can now repeat it to get the same results. Then your hypothesis might turn into a theory.